Okay, so this is an overview of the SEER Ply Cost Estimator capability for composite estimation that sits within CATIA V5. What Keith is going to do in a moment is go through the process of creating an estimate, creating and viewing the results of that estimate, and understanding how the rules and other environmental factors can be calibrated for your particular needs. And as I say, this is the SEER Ply Cost Estimator for composite estimation within CATIA V5. You are currently viewing Keith's desktop. Keith, over to you.
Okay, so we have a composite component on our screen within CATIA, and to the top left you'll see the 3 buttons that get installed when you have the SEER tools for CATIA, the first one being the Ply Cost Estimator. I'll click that, and as I click it, the model will interrogate the geometry of the part. It will come in and load it, and the little dialog box will appear, and this has already captured geometric tolerances, things to do with the part, etc. And from here we now decide how we want to manage this part. With reference to your own type of part, we have environments. So the tool is designed that you can build and create your own environment, whether it be for aerospace, whether it be for automotive, whether it be for industrial, commercial, whatever you want it to be, to reflect your capabilities, your efficiencies, your inefficiencies, your processes, your product line, your component types, etc. So we'll assume this is an aerospace part. So I'll select aerospace here, and today we're going to hand layout. We could have done automated tape layout, we could have done toe placement. So we'll do hand layout at the moment, and we'll tell the model that we wish to make 100 of them. We'll select the part shape, which is a C-section, which is coming with the recommended shape complexity for laying up this type of component. The length, the part width, and the thickness is already ready for use within SEER, as is the ply table that we'll look at later. The process options, these are set by the rules file. They're only defaults, so for this instance, we're assuming we would use ultrasonic cutting equipment. We're going to use a laser to locate the plies. We're going to be using a reusable nylon bag type, and we're going to debulk every one. We're not sentenced to that. They're just default. So we could say we're going to use a gerber knife. We're going to use a template. We're going to use a simple nylon bag, and we're going to debulk every 4th interval. We're not hot debulking. We don't have a quarter machine. We will do NDT. We will have tool fab and design, and we will do some finishing operations. Again, these are yes/no options within the environment that we look at. The material details comes in from CATIA, and we can also add additional drilling ops. We can add them. We can give it a description, tell it what type of drill we're using, the quantity of hose, diameter, depth, pitch, etc., whether we need to finish ream them, and we can add them as a growing list to cover what needs to be put into the component. The model will give you a trim length for all of the external periphery. If we had some windows here, we could add them to the list for additional trimming if necessary. So we've looked at all of the tabs. We're ready to go. We simply press on Estimate. The model is now opening SEER for manufacturing, which is the costing engine in the background. It's creating a work breakdown structure, generating an estimate based on the ply table, the sizes, the materials, the processes, the debulking. And when it's done, it will then bring that estimate back and present it to you within CATIA. So we can see that we have a summary of all the costs. We have our direct hours, our setup hours, our inspection, our rework, material costs, giving us an overall cost for this given component. We can save the information into the tree for CATIA itself. Over here, we have the parameters, so we can see it's not opening. It should open. There we go. So it's telling us what the material are, orientations, the laminates, and so on and so forth within it. Composite 3D, all of the thicknesses, the geometry, etc. Standard from CATIA. So we can have a look at SEER now. So we want to show the SEER estimate. So we go into the background, and this is the resultant estimate that SEER for Manufacturing has created. Now, if you were doing this in a 2D environment, this is exactly what you would do. You would create a structure for your layup, your NDT, autoclaving, trimming, and finishing as required. So if we look at this, we can see we have a color-coded set of parameters. These are coded simply to highlight which are set in the environment, which are set in the interface. So we can look at the notes. It's just telling you that's where we told it we were making 100. The rule said we were going to do a setup amortization every 1. Labor rates, product classification, experience are all part of the calibration process that we would go through with you, help you, train you to cover within your environments. Process specific, this is where SEER has done its work, is extracted the sizes from CATIA, it's brought in this ply table, all of the plies, and we told it we had a gerber knife template, and we can see that reflected in our estimate here now. So I'll click on one, and you can see it's brought in where it is within the sequence. In CATIA, we have 1 ply, the roll width, cost, CATIA material, gerber knife, etc. 90-degree orientation, covering 41% of the total area of the part, and we're going to have a setup for it as well. So it does that for every ply. Other things at the bottom are to do with, we selected nylon, we selected 4, we didn't want hot ply, so there's none of them, and we got utilization, again, controlled within the rules for CATIA. If we look at the available reports, one of them is an aero detail report, which I'll highlight, click on OK, and if I double click this one, we can pop it out, we can have it on a second screen, and it will give us a full breakdown and coverage of what's gone on within the estimate. So this is for the hand layout. If we look at the autoclave, we'll have different set of inputs, different results, trimming, again, different processes, and so on. So it's available for each of the aero type operations that it's using. Window, arrange all, puts everything back nice and neat. So you have the capability now to accept the estimate, deliver this, give it to a purchasing department, quotation, shop target, bidding, proposals, whatever you want to use the estimate for. You can also refine the estimate here. You could add some pill plies, you could add some additional operations, you could add some assembly operations. So we have a wide range of processes that are available that you could use within SEER. So these are the standard operations available within SEER for Manufacturing, and you can add that to this estimate for something that's not maybe covered within the interface. So if I minimize this one, we go back into CATIA, and we decided we want to do something slightly different. So we'll modify the estimate. We'll go to the part inputs, choose another one maybe. Let's say it's a commercial part, and we're doing it using hand layout maybe. Process options. So we're debulking it every 6. We're using laser, we're automated, we don't have core. They're not worrying about the testing to the same degree, tooling's covered, and we can estimate that. And you can do quick what-if iterations as well. And obviously, if you're CATIA trained, which I am not, you can make modifications to the plies and geometry, press a button, have a look at what is the impact of that change. You can see that this time we saved an awful lot of time. Basically, that's because we've removed all the tooling costs. So it's a 90% drop in cost. So it's not strictly a fair comparison, but that's why that number is so good. So again, we can modify the estimate. We can say, actually, we did want tooling, and we'll estimate it again, and we'll see other differences. That's how the model works in the background. Now, the rules, the environments are all driven from a controllable medium in the background, one of which is a Excel file, which contains the rules. One is a SEER for manufacturing file, which contains all of the estimates that are held within MFG that creates the knowledge bases that run with each individual environment. So if I quickly go to Excel and open, sorry, let me just go here. This is an environment. So if I double click on the editor, this is a sample. We're not going to go into the details, but this is where the basics are set up. So we're going to say that for this environment, we're working in aerospace, US dollars, hand layup, panel, ultrasonic laser. This is where we can change it. We could change the default to German. We don't have an ultrasonic machine. We don't locate using laser. We use templates. So this is just the default to get you started. And you make those changes all the way down through the rules, all the things associated with autoclaves, with resin transfer molding, with vacuum assisted resin transfer molding, etc. Drilling features, the part shapes, bag types, trimming, material boundaries, etc., etc. And that is what we set up with you, for you, on your behalf, train you how to do it, so that you create one for aerospace spars, aerospace ribs, aerospace panels, shelves, whatever you want it to be within composites, we can do that. This works in conjunction with the SEER for manufacturing environments file, this one, and each one of these are set up again. You tell it your labor rates, you tell it your product classification. This could be a commercial part. We can set it to nominal maybe, and you would set all of these to nominal, and you can do that quite quickly, quite easily by changing multiple parameters at one time. You put in your labor rates, tell it what your rates are, and all of a sudden the model starts to reflect your manufacturing environment. You've got some really good guys, very experienced, we can tell the model that. So the way that's working now, we've reduced the product classification, so it's going to be easier to make. We've told the model that we're better, and we told the model we're at a lot lower rate. So this is going to be a much cheaper estimate if we ran it and saved it. On the process specific, again, the green is coming in from CATIA. Shape complexity, you're setting up yourself within the interface, and all of this is coming in as part of the rules as well. So that's what's going on. Each one of these are reflected for sandwich machining, sandwich layup, core layup, autoclaving, RTM. Each has their own individual process specific. Looks a lot of inputs, very, very good engineering speak. Anyone that knows anything about composites will have a good idea of what these inputs would be for your given processes and your given capabilities. So just minimize that one. We'll minimize that. So once you are ready, you would save this, click on it, and it will say, I didn't want to do that. Never mind, it's going to go off and save the knowledge bases, and it will come back and tell me that it's saving them together. So that's SEER for Ply Cost Estimator. It's very comprehensive, very capable. You can have big parts, simple parts, very, very complex parts. And that's basically a general overview of its capabilities, how you would train it, teach the model, how you work, what your processes are, what your environments need to be to reflect it. And it will give you, like I showed you, comprehensive reports. These could be exported into Excel to parse into forms that you may wish to report. It saves the estimate into the tree. It's captured, so you have this history within CATIA of its cost, so that your designers can come along, make the changes as desired, look at the impact of those changes, think, hang on, this is not a good decision, we've doubled the cost of this part, can we do something better? Can we try different costs, different geometries, and try to design to cost and take control of your cost for your tool. Thank you very much. Back to Steve.
Excellent. Thank you very much, Keith. Obviously, this is a general overview, and Keith's covered all of the aspects at a reasonably high level. If there are any questions, we can cover those in a more detailed session again. Also, you all have our contact details, so please feel free to email us. Thank you very much, and let us know if you have any questions. Thank you.